A radius of a sphere is to be 3 centimeters with a possible error of 0.02 centimeters. We want to use differentials to approximate the maximum error in calculating the volume. So this change in volume is called propagated error, and we can use differential V to approximate delta V, the actual change in volume. So using the volume formula for a sphere, volume equals 4/3 pi r cubed, differential V is going to be equal to the derivative of the volume function with respect to r times differential r. So looking at the given information again, the radius will equal 3 centimeters, and the change in r, or differential r, is going to be equal to the possible error of plus or minus 0.02 centimeters. So the only thing left to do here is to determine the derivative of the volume function with respect to r. So v prime of r is going to be equal to 4 pi r squared. So the propagated error, or delta v, is going to be approximately equal to differential v, which is equal to the derivative of v evaluated at r equals 3 times differential r, which is plus or minus 0.02 centimeters. Now we'll substitute 3 in for r into the derivative function and then multiply it by plus or minus 0.02. Now let's go to the calculator. 4 times pi times 3 squared times 0.02 . So because of the error in measuring the radius, the volume can be off by plus or minus 2.26 cubic centimeters. Now sometimes this is hard to determine whether this amount of error is acceptable or not, and so often you'll also be asked to determine the relative error, which compares the propagated error to what the volume should be if r was actually equal to 3. And it's normally expressed as a percentage, so our relative error is going to be equal to differential v, which we already found as plus or minus 2.26 divided by the volume of the sphere if r was equal to exactly 3. So we'd have 4/3 times pi times r cubed. Notice how one factor of 3 is going to simplify out here. So we'll have plus or minus 2.26 divided by, this is going to be 4 times pi times 9, that's 36 pi. Let's go to the calculator. 2.26 divided by 36 pi. So it's approximately plus or minus 0.02, which would be plus or minus 2%. So notice when expressed as a percentage, it does give a better feel for how much of an error we can actually experience with the radius being off by plus or minus 0.02 centimeters. I hope you found this helpful.